This comes out of section 8.2, derivatives of exponential functions. So let's start off with just a general exponential function y equals b to the x. We know that if b is greater than 1, that's exponential increase. If b is between 0 and 1, it's exponential decay or decline. When we've done derivatives and didn't know what to do with them, we've used first principles, and that's kind of where we're at here. We've never taken the derivative of something where the variable was in the exponent before. So if I look at what's y prime going to be, I'm going to start with the limit as h goes to 0 of f of x plus h minus f of x over h. It's right back to the very beginning of the course, and we say limit as h goes to 0 of b to the x plus h minus b to the x over h. Try to simplify that a little bit. I get the limit as h goes to 0 of b to the x times b to the h minus b to the x over h. I'm just using the fact that when you multiply two things with the same base, you can add their exponents, so kind of doing that in reverse. So here I can factor out b to the x, and it leaves me with b to the h minus 1 over h. So it turns out that the derivative of b to the x has a b to the x in it, but then it also has this, whatever the limit as h goes to 0 of b to the h minus 1 over h is. Now, if you tried putting in h as 0 in there, you're going to get 0 over 0, which is our indeterminate situation. But if you do put in some numbers, let's say, for example, if b was 2, so we have exponential growth, and we've got b is equal to 2, what you'd find is that the limit as h goes to 0 of 2 to the h minus 1 over h, and in this case, since we have no special method, I'd put in tiny numbers for h, 0.000001, etc., and I get that this equals about 0.69. If I try another number like b equals 3, this limit gives me 3 to the h minus 1 over h. It gives me a little bit bigger than 1, about 1.1 roughly. It turns out there is one number that gives me an answer of 1 there, and that doesn't seem like a big deal, but it means that, so if instead of b we use the letter e, the number e, which again, remembering that e is 2.718 decimal, if you put that into this limit here, e to the h minus 1 over h, the answer here is 1. Now what that means is something actually pretty remarkable, is that if you have the function y equals e to the x, the derivative of that function is y equals e to the x. If we would have had y equals 2 to the x or some other thing, it's quite similar. You do get a 2 to the x, but you have this other extra term, and it turns out that it's the natural log of 2. So if I had y equals 3 to the x, the derivative is 3 to the x times the natural log of 3. But the one we're really going to spend time with here is the exponential function, where we use e to the x, and the derivative of it is e to the x. And we'll use that in our next example.